Hello everyone, welcome to my channel. In today's video, we are going to continue our studies in regression analysis. In our previous video, we looked at regression analysis, that's the concept of regression analysis, where we look at how to compute regression analysis, the simple linear regression and the multiple linear regression manually, and solve some case study examples. In this video, we are going to continue our studies using Excel. So today we are going to look at how to compute the regression equation using Excel and use it for prediction for the simple linear regression and the multiple linear regression. So kindly stay with me. So we have a simple data here that we are going to use, and then we are asked to predict students' exam score based on their study hour, or the study hour, that is the number of hours that the student study. So we are going to use regression to do that prediction. Now it's very simple in Excel. So the first thing that you can do, there are two ways to do it. For a simple linear regression, there are two ways to do it. The first is to go to your Insert tab, and then you check for the charts over here. And then when you check the charts, you can either select everything and then click on this icon to get all the charts, or you select your data and then click on this one. When you click on this, you see that we have scatter. So you use any of the scatter plots over here. So let's choose this one. This is what we want. So instantly you get a scatter plot of your data. And to insert the regression equation and then the line of best fits, all you need to do is just click here and then choose trend line. When you choose trend line, you realize that automatically the regression line will be inserted. So let's click on it, and then there is an option for you to continue. So choose the option here. You see you have the linear and then the exponential, so many lines that you can draw. But what we are interested is in, go to the more option, click on the more option, and then you have your format trend line panel open. Then you scroll down, you will see that when you scroll down, you have the display equation or chart. This will display the regression equation for us. So in this case, you don't need to do any calculation again. Once you click on it, you have the regression equation displayed. So let's come back to our charts and then push the regression equation to somewhere here. And we can format the chart. So now this is our regression equation. It has been given to us straightforward. So this time around, we don't need any much work. All that we need to do is just to plot. Now, when you want to, this is the equation given to us, so we can use it to predict anything at all. So let's say that the student is studying for, if the student has studied for, let's say 9 hours or 10 hours, then we can use this to predict it. So over here, when you compare with the regression equation, you realize that the y predicted is equal to beta naught plus beta 1 x. Okay, so here the beta 1 is the beta naught is the 45, and then the beta 1 is our 5 over here. So if we want to compute for, if let's say we want to predict for 10 hours study, we want to predict the score for 10 hours study, what we need to do, it means that we are going to have 5 multiplied by 10 hours and then plus the intercept, which is 45. So our intercept is 45. Let me put the 10 hours here, and then when I come here, let me say that equal to, and then this one, that's the 10 hours times 5. So that's the beta 1, and then plus our intercept, that is the b naught, which is 45 from the equation. So once we hit, it means that when a student study for 10 hours, the score will be 95. So that is the prediction. So that is one way that we can do we can do the regression. Another way that we can also do it is to use the data analysis toolbar. So let me put this down here, and then we go to For you to get the data analysis toolpack, all that you need to do, come to the data tab. When you come to the data tab, you will see the data analysis over here. If it is not activated, yours is not activated, you go to your file options, then you scroll down to option. When you come to the option, you come to add in. So you have the add in, and then when you click on the add in, you will see the Excel over here. So you have the Excel add in. Then you click on what you want. So when you click on the go, you will see the add-in that you want over here. We have the data analysis, that's analysis toolpack, that's VBA and others. I'm interested in the analysis toolpack. So once you click on the analysis toolpack and then you click on OK, automatically it will appear here because now you have added the add-in. So now we have it here, and then what we need to do is we need to click on it, and then we are looking for regression. So you scroll down to where this is regression, that's what we are looking for. You click OK. So the first thing that it will ask you is to select the range. Let me delete what I have inside. So it will ask you of the range for your, that is the dependent variable, which is y. So you are looking for the dependent variable. You click on it, and then you come and select the dependent variable. This is the dependent variable. So you click on it, then OK. And then the y, the x, which is the independent variable, you also select it together with the title. And then you indicate that there is a label because you have selected it with the title. You indicate that there is a label. So once you indicate it, now the next is output range. There are many options. You can either output the results on a new worksheet, a new workbook, or the range. I want it to be on this same worksheet, so I will select the range. So let me just click on it and select a place. So let me pull this one on top, and then let me select this place and click OK. So now all that we need to do is click OK, and then you have your results. So this is the results. So let me expand them, and then you look at them. So this is the result that we have. Let's go to our whiteboard and then explain it on the whiteboard so that we will also move on with the multiple linear regression as well. So I'll just copy the whole of this and then put it on my whiteboard, and then we look at it. All right, so this is our results of the simple linear regression. So let's look at what it means and some of them. Now, for the first one, you have the regression statistics, and then the second table we have the ANOVA, and then we also have the last table. Now, our result, we will focus more on the last table, but let me just give a brief description of the first table. So with the first table, we have the first thing that we have over here is the multiple R. So that is, we have the multiple R. Now, the multiple R here is telling us that is the measure of the correlation between the dependent and then the independent variable. And then a value of 1 means that there is a perfect linear relationship between the dependent and independent variable. But if it approaching 0, it means that we have a weak relationship. So this R, multiple R, is explaining that, is showing that, and then we are having 1 in our result, showing that there is a strong or a perfect relationship. The second one is the R square. Now the R square, we also call it the coefficient of determination. And with this, it indicates how well a regression line fits the data. So that is our regression line model, or the regression line on our chart, on the chart that we had, how well that particular line fits the data. So this one is also explaining it. And we are having also one here showing that there is a strong or 100% variation. Okay, so it means that 100% of the variability in the exam score is explained by the steady hour. So which means that it just indicates how well the regression line fits the data. So meaning that the regression line for the exam score and really fits the data of the steady hour. So that is what it's also telling us. And then we also have the adjusted R square. The adjusted R square also measure how well the linear regression model fits. It's kind of the same thing, similar to, not the same, but similar to the R square. And then we have the standard error. Now you can see that here is it's in scientific notation, and which is 2.2352 e minus 15, that is 0.000150 actually. So it means that here we are saying that the standard error measures how accurate the value predicted is. So it is how accurate the predicted value is. That is the value predicted is by the regression model. So when we have a small value, it suggests that there is almost no variation or variability. So we having a small error or 0.0000 error shows that there is almost no variation. Though there is some kind of variation, but it is too small, negligible. So you can just a negligible error. Yeah, so that is what that one also means. And then the observation is just showing the number of observed data that we have, the data points. You can see that it started from 1 to 8. So that is the observation. Now the ANOVA table, that is what we are looking at right now. The ANOVA table. So the first one, we have the regression, the residual, and then the total. The total, we just leave it aside. And then the regression. Now the regression, the first one is this one, that's the degree of freedom, and then the residual. Now you can see that here we have SS and then the MS. So you have the SS and then the MS, and then we have the F, and then we have the significance F. So let's take them one by one. Down the sum of square, the SS means sum of square, and then it explains the total variation in the dependent variable by the regression model. So that is what is the total variation in the dependent variable. And then the second SS, we can see that the first one is the regression SS, which is regression sum of square, that is RSS. And then the second one is residual. So we are looking at, and then the residual is also measures how well the regression model fits the data. So a very tiny one implies that a negligible unexplained variation. So like this one is also trying to explain the variation in the data or the variation in the model. And you can see that this one is also 2 points up to minus 29, which is also very a tiny value or a negligible value. So there is a negligible unexplained variation because the error is too small. So that error cannot be explained. So that is what we are trying. That one is also telling us. And then we have the F statistics. The F here is the F statistics. And the F statistics is a test it tests the overall significance of the regression model. So what is the significance of the model? How important is our model? Is it accurate? So this F is actually testing that. It's evaluating whether the independent variable explains a significant portion of the variance in the dependent variable. So our independent variable, how well did it explain the variance in the dependent variable? Which portion, how significant portion, which portion did he explain? So that is what he's also telling us. And we can see that here, this one is actually giving us, let me clean this, and so that you see it clearly. You can see that this one is actually giving us 2.10 e plus 32, which is a very big value, plus 32. So it's a very big value, showing that our regression model actually explain the independent variable actually explain a very large portion of the variance of the independent. So that is what this particular one is telling us, showing that our regression model is very, very significant. It's very, very, very significant. It explains almost all portion or a very large portion of the model. And then the last one, which is significance F. Now, in regression analysis, we always set hypothesis, and then with the hypothesis, we have the null and then alternate hypothesis. So we have the H naught, which we normally say that the H naught, which is equal to, or which is, that is the null hypothesis, showing that, and mostly it is for beta 1. And we see that here the beta 1 is equal to 0, which means that here what is trying to say is that there is no relationship between the dependent and independent variable. That is, there is no significant relationship. There is no significant relationship. And then the other one is H1, which is the alternate hypothesis. And then that one is showing that no, beta 1 is not equal to 0. And when beta 1 is equal to 0, you realize that x will also be equal to 0. That's the dependent variable. The independent variable will be equal to 0. Because our regression equation is given by this. We know that our regression equation is given by y predicted to be equal to beta naught plus beta 1 x. So at any point in time, beta 1 is equal to 0. It means that x is also equal to 0. Hence, the regression, there is no importance or significance of the independent variable in our model, meaning that the x over here is not important in our prediction. So the null hypothesis is saying that beta 1 is equal to 0, showing that there is no significant relationship between the dependent and independent variable. And on the other hand, the H1, that is the alternate hypothesis, is saying that there is a significant relationship. Because there is a significant relationship, beta 1 is not equal to 0. So that is what he's saying over here. And there is an upper value that we compare the F and P value with, which is equal to 0.05. And we say that at any point in time that we have this, our F, this value, when it is less than or equal to, so we say that, let me write it. So P value, when P value is less or equal to alpha, we reject. So reject the null hypothesis. So reject H naught. So reject H naught. And when P value is greater than alpha, when P value is greater than alpha, fail to reject. So fail to reject. So we fail to reject. So at any point in time that we have our P value, which is less or equal to this particular value, we reject H naught, showing that the H naught, which says that there is no relationship between them, we fail to reject it. And when we have a P value which is greater than alpha value, we fail to reject it. So we fail to reject it and conclude that there is a significant relationship. So that is what it means over here. So over here, this is our P value, this is the F statistics becomes our P value. So the F statistics over here, you can see that it is way beyond the 0.05. It is way beyond this particular value. It is 7.27e minus 96, which is 0.00000, and it's too small, which is smaller than this, which means that this particular value, our P value, which means that, let me use this color, which means that our P value over here is less than, this one is not even less or equal to, it's less than our alpha value. So because it's less than our alpha value, we are going to reject the null hypothesis, which says that beta 1 is equal to 0, meaning that there is a significant relationship. So there is a significant relationship between the dependent and independent variable. So that is what it means over here. Our p-value is way, way, way less than the alpha value. So what we are going to do is to reject this particular one. So you don't accept this particular statement that the h naught beta 1 is equal to 0, meaning that if beta 1 is equal to 0, then our equation now becomes y is equal to only beta naught. So x, that is the independent variable, has no impact, no relationship with the dependent variable, which is very wrong. This statement over here, our analysis over here, this particular value is telling us that this is wrong, this is not true, which means that we fail to reject, or we reject the null hypothesis, and then we conclude that there is a significant relationship between the dependent and independent variable. So that is what it means over here. So we reject this particular one, we reject this one, we reject it and accept this one. So that is what it means. So now move on to the next one. So that is all about this particular table. And then the last table, we can see the last table over here. We have the coefficient, the standard error, the t statistic, the p-value. For with these particular p-values, they are for each of them, how significant they are in the model. So here we can see that they are all less than the normal alpha value, which is 0.05. So they are far less than. And we have the lower 95% of the data, and then the upper 95%, and then all that. So let's look at this. Now, how do we get our equation? We can see we have the coefficient over here. So this particular coefficient is the one that is going to give us our equation, and that is what will also help us to make our prediction. With the steady hour, we can see from the steady hour, this particular one is the coefficient for, that is for the value for beta 1, because that is for the x. You see, in our regression equation, or in our table, we have the steady hour being the independent variable, and then the exam score being the dependent variable. So the steady hour is over here, which is our s. So that is our s. So because we have it over here, we are going to use it in our prediction. Now, this particular prediction simply is we are going to have our beta naught is equal to 45, and beta 1 is equal to 5. This is the intercept. So when you draw the regression line, this is where the intercept will be. This particular one is the intercept, the 45. That is our beta naught. And then the steady hour, which is our independent variable, is 5. So our new regression equation is now going to be, this is our new regression. We are going to have y will be equal to the beta naught, which is 45, will be 45, then plus, then beta 1, which is 5, and then x. So that's what we have. And that was the equation that we had when we draw the chart. So this is what we have. Now, if you want to use this for prediction, just as we did the other time, is to just use your equation. Let's say we want to predict for, we have 10 hours of steady. So we have 10 hours of steady, and we want to predict the exam score for this particular one. So the exam score for 10 hours will be equal to, we have the 45 plus 5 multiplied by 10, and this is what is going to give us our the exam score that we are going to get. And this one is, we have 45 plus 50, 10 times 5 will give us 50, is equal to 95%. So meaning that if a student study for 10 hours, the student is likely to get 95% based on our data. On the other hand, if the student didn't study at all, meaning that the number of hours studied is 0, it means that the student will get 45, which means that the student will fail. So in that case, This is our equation. Our equation will now be equal to, we are going to get, in that case, it will be like this. So let me draw a distinction between them. In that case, you are going to have 45 plus 5 into bracket 0, because the number of hours study is 0, and this is going to give us 45. So if the student didn't study at all, the student is going to score 45%, and that is below 50, so fail. So that is about the simple linear regression. When you use Excel, how you can interpret it. Now let's look at the multiple linear regression, how that one also. With the multiple linear regression, it's follow the same procedure, but let's look at how we can also do the same thing with an example. So with the multiple linear regression, this is the data set also given to us. This is the data set, and this one we have to predict the house price based on the size, bedroom, and age. So this is our data. We have the house ID, the size, and then the bedroom, then the age and the price. So we have to predict the house price. Now all that we will do over here is just to go straight to the same thing. Now we already have the data analysis toolpack activated, so we just click on it and then we choose regression analysis. So we choose regression, and now we have this. The first is we want that is the dependent variable, the y. What is the dependent variable? You click here and then you select it. Is this one, the price? That's what you want to predict. So you choose the price. Then you come to for the x, that is the x, which is the independent variable. You have the two, because it's based on the size, bedroom, and then the age. So probably the age of the house. So you choose that one too, and then the data is having a label, so the label is checked. And then where do you want the output range? Clean this away and choose new output range. So let me choose somewhere here. Good. Okay. So these are, you see that we have the confidence 795, and then you click OK. So this gives us also the results of our regression analysis. So now let's also copy this one to our whiteboard and then look at what each of them is telling us over here. So this is what we have over here. Now this one also means just the same thing as we have. Now you can see over here, this is not close to, it's close to 1. So we have 0.9, 0.7, and then the adjusted R-square is 0.96, and then the standard error, and we have also this. So this is also okay, and we have this particular table. Now this is where our focus is. So we have, this is our focus. This particular area is what we are interested in, and then this particular one to get our equation. So the first one over here, the first one that we have, you can see that we have the F statistics and then the p-value, which is a significant F. And then the F statistics is 60.78, which is okay. And then we also have this, and this value over here, which is F, a significant F, you can see is far less than 0.05. So this is less than 0.05, meaning that we are going to reject the null hypothesis and conclude that there is a significant relationship between the independent variable and the dependent variable. Because this value is less than 0.05, there is a relationship between the dependent and the independent variable. So now let's look at this. Once there's a relationship, we can also look at, now you can also look at this particular area. You can also look at this area. That's the p-value for each of them. Now with the p-value for each of them, you can see the first one, and this one is the intercept. You can see there is a kind of this one is, that is for the size. The size is far less than 0.05, which is, we have 0.03, and it's less than 0.05. And then we have the bedroom, which is 0.07. It's not less than, it's greater than. And then we have the age, 0.1, which is also greater than. It shows us that these two, these two, that is the bedroom side, the bedroom, that's the number of bedroom, and the age, is not contributing much to the regression. That is, it's not really significant. So if we don't include it, we can still, our model will still be significant. We can still be able to predict the price correctly. So once these values are too big, you can decide, you can remove it and then do another regression analysis. So you exclude them and then you go and do your regression analysis again. In that case, if we exclude the two of them, it means that we are going to have a linear relationship, a linear regression, which will be between the dependent variable will be the price, and then the independent variable is going to be the size. So that is all that it means. But what we are going to do is that you look at the bedroom, you see that though it's not less than 0.05, it is somewhere close. So it means that it's giving us, it's contributing a bit. And then for this particular one, it's too big. So when you use it to predict, it will be okay. It will give us a go ahead, a good model. But we will also try to remove it. And now let's do this particular one, and then we'll do another one again and exclude the age and see how our model is going to fit, what is going to give to us about the model. So now we know that with the multiple linear regression, this one is having 3 independent variables. So it means that we are going to have y will be equal to beta naught plus, we have beta 1 x1, beta 1 x1, beta 1 x1 plus beta 2 x2 plus beta 3 x3, and then plus the error term. So you can see that we are having 3 independent variables, this, and then this. So that is what we have. So if we want to form this particular regression equation with this particular value, this first one is our beta naught, and this is our beta 1, this is our beta 2. So let me write them. We have this one as beta naught, and then this one as beta 1, beta 2, and then beta 3. So that is what we have. So our regression equation will be given us, we will have y will be equal to, the first one is the beta naught, which is 153 points. Let me run it to 3 decimal places. So you have 153.619. I'm running it, so 8 will be 9 plus, and then we have beta 1. Beta 1 is 0.072 x1 plus beta 2. Beta 2 is 20.734 x2 plus, and then we have the last one, beta. Now the beta 3 is negative, so it will be minus, and then we have 1.495 x3. So this is our regression equation, or our prediction equation, and that is what we are going to use to predict the price of any given house with the size, the bedroom, and then the age of the house. So that is it. Now the next one is, because we have this particular one being insignificant, let's remove it, let's take it out, and then do the regression analysis again and see the differences, what we are going to get. So let's do the regression equation, that's the regression again, and then we want to remove the age. So this time we want to remove the age. So it means that if we want to remove the age, we are going to only use the size and then the bedroom as the independent variable. The age is not included. So let's go to the regression again, and this time around the y range, which is the dependent variable, is the same thing. So let me just change only this one, and this time around I need only these two, so I'll select only these two. Okay, and then where do I want to put that? Let me scroll down. I want to put it beneath this particular one, so let me choose this side, and then I'll say okay, and then I have it. So this is the result I also have from this one. Here you can, when you look at it, you see that they have been a bit different. The difference there's kind of difference between them. You can see the significant difference, that's the significant value over here, which is, and then the F statistic, which is 50. Instead of here it was 60, it was 60.78, but here it's 58, and it's still strong. And then here we have 0.0003, and here we have 0.0008. Now, when you look at the regression equation over here is going to give us different equation. You have the coefficient to be, that's the beta naught will be 83.448, and then we have the beta 1 to be 0.0793, and then the beta 2 will be 31.034, which are all different from this particular one, and this particular one gives us another equation. But if you compare the two of them, you can see this one will predict better than this particular one. This one is actually going to predict better. It will give us a better prediction compared to this particular one. So that is the difference between the two of them. So sometimes that is how the regression analysis, if you have so many multiple independent or so many independent variables, some of them will not be a better predictor. So you end up taking some of them out and then leaving only those that are better predictors, those that can predict very well in the equation. So when you look at this first equation, that is the first analysis, you realize that age is not a better predictor over here. Age is not predicting very well for us. So that is why we decided to take it out. And here you can see that all the remaining ones are good predictors and they are predicting very well for us. Now when you look at the p-value for the two of them, you can see the p-value for them and you can see that they are all less than 0.05. They are all less than 0.05. For the p-value for the size is 0.03, and then that of the bedroom is 0.01. So they are predicting very well for us over here rather than this place. So that is the difference between the two of them, and that's how we can perform regression analysis in Excel. In our next video, we look at how you can perform regression analysis and prediction in R and Python. So stay with me. Remember to subscribe to the channel, like the video, and share with your friends. Thank you.